Hello, geometry students. We are looking at day 6 of our right triangles unit. And what we are doing today is inverse trigonometry. So when it says, what are the 3 inverse trig functions? Well, the same 3 trig functions, sine, cosine, and tangent, can be used in the opposite direction, and they are inverse sine. And so we use a little sign to the -1 to show that, inverse cosine, and then inverse tangent. And so all of them would actually just read as inverse and then whatever term it is. So like sine and so on. Okay. That's how you'd actually read these here. How you use them. Well, we're still going to do the same setup with SOHCAHTOA to start. So when you take a look at this first question and it says use the right triangle to find the missing angle, round your answers to the nearest tenth. Okay, if here's the angle that I have, labeling the sides appropriately, this would be the opposite side. Across from the 90, that's the hypotenuse. The leftover one here would be my adjacent. The 2 sides that I have to work with are the opposite and the hypotenuse. So I would still say, all right, opposite hypotenuse, that's going to be sine. So we just want to set it up. So what we have here is sine of x degrees is equal to 8 and then over 21. You can't cross multiply because I don't have a number to plug in here. So when you're trying to undo sine or get rid of it, you can't divide sine out. You're not multiplying by it. You're taking the sine of something. So to undo it, what you do to both sides is you would use the inverse sine function. So if you do inverse sine of x, and then you would do the inverse sine of 8 over 21 on the other side, this part cancels because literally that's the inverse operation. And what I'm left with is x. And then into my calculator, I'm going to use this. So when you grab your calculator here, what you'll notice is above the sine, cosine, and tangent buttons, I'll zoom in a little bit here. You'll see that little sine inverse, cosine inverse, tangent inverse. So to access those, you have to hit second and then sine. And when you do that, you should see the little sign -1 pop up. And then you can type in 8 divided by 21, close it up. And then what it's producing for you is the angle measure that would have that ratio of opposite over hypotenuse. So 22.4 degrees should be our answer here. So that's our angle measure. So let's try it again. With the second one here, start with where x is. This is the side opposite. Here's my hypotenuse. Here's the adjacent. So since the opposite and the adjacent are labeled, by now we should be able to know that that's our TOA, that's tangent. So tangent of x, and then equals the opposite 14 over the adjacent 11. All right, you're going to take the inverse tangent of both sides. So I'm going to do inverse tangent of x, and then inverse tangent of 14 over 11. This will cancel. And then into my calculator, I can type second tangent, and then 14 over 11. And that's going to give me 51.8 degrees as my answer there. So it's pretty simple. As you're showing the work, you might start to be able to shortcut a little bit of the steps. So let's do that with number 3. So here's my x, side opposite the hypotenuse, or is the opposite the 90 degrees, sorry, is the hypotenuse. And then my side next to it's the adjacent. So we have the adjacent and the hypotenuse here. So when we set this up, a over h, that's going to be cosine. So I still want to see cosine of x and then equals 16 over 27. And then what people will often do is go right to saying that x is equal to the inverse cosine of 16 over 27, like that. And so rather than showing that you're taking inverse cosine on both sides, we kind of just go from here to here. If that'll confuse you, then you can show it exactly the same way you did the other ones. Otherwise, grab your calculator, take the inverse cosine. X is coming out to be about 53.7 degrees. And there you go. All right. Let's save that last guy for class. So hold on to that one. All right, flip it right on over to the next page. So on the next page, these two questions are asking you to find every missing side and every missing angle. So you have an option here, depending on what information is given, to find missing sides and angles of right triangles. We have Pythagorean theorem as an option. And then we have trig as well as now inverse trig is an option. So this first one, you're given two side lengths. If I'm going to find that last side length here, my thoughts would be to use Pythagorean theorem. It is so tempting to look at this and go 3, 4, 5, but the 4 is on the hypotenuse. So that can't be a 3, 4, 5 right triangle. So if I want, I can put a little X here. This would be my A, my B, my C. And in that case, I can go 3 squared plus X squared equals 4 squared. This will give me 9 plus X squared equals 16. Subtract that over. That gives me X squared equals 7. And then we take our square root. Now the directions do say round your answers to the nearest tenth. So even though we'd have an exact value of radical 7, and feel free to keep that, it does say go ahead and round. So let's just grab our calculator. Square root of 7, that's coming out to be about 2.6. And so that would be that last side length here. So approximately 2.6. Now, something to keep in mind. When I now want to go solve for the angle measures, if I use this side length and I use the rounded value, it can throw off those answers. So my suggestion is use the two lengths that are given to you when finding any of the angle measures, or use the exact radical that's not rounded if you're going to use that side to find the angle measures. So what I mean by that, let's come on down here. I'm going to call this Y right here. If that's my angle that I'm going to find first, this is then the adjacent side. This is my hypotenuse. And so adjacent hypotenuse, we'd be using cosine here. And so I would do cosine of whatever Y is equals adjacent over hypotenuse. Here's a perfect case where I don't have a value there, so I'm going to be using inverse cosine of 3/4 to get that value. So on my calculator, second cosine of 3 over 4, and that comes out to be 41.4 degrees. So that's this guy, whoops, right there. And then as for that last angle, you could do some more trig to find it, or I can use the idea that the three angles of the triangle add up to 180. And so if I go 180 minus the 90 in that corner, minus the 41.4 in the other corner, I can get my last angle measure that way. So 180 minus 90 minus 41.4, that's going to leave me with 48.6 degrees right there. And so that is the complement of this angle right here. All right. There's my 3 answers. Number 6. Let's save it for class and let's move on. So on to the next page. You have a graph. I've already sketched mine. If you need to, feel free to pause the video so that you can plot the points of A, B, and C. And it turns out you can see it's a nice right triangle because we have a horizontal and a vertical. And it's asking us to find the length of AB to the nearest tenth. So when you're on a graph, you can count any horizontal and vertical distances. So I can count AC and BC to get those lengths. So I have 1, 2, 3, 4, 5 this way for AC. And then 1, 2, 3, 4, 5, 6, 7, 8 for BC. I'm going to use those two as my A and B into A squared plus B squared equals C squared to solve for AB. So 25 and 64 together, it's going to give us 89. So not a perfect square, but that's okay because the directions say round to the nearest tenth. So that's usually code for, oops, it's not going to be that pretty. All right, so if we take the square root of that, 9.4 to the nearest tenth. So AB will equal 9.4. So I can either box it in here throw it up there, whatever works. All right, for part B, find the measure of angle A. Again, I don't want to really use my rounded answer here, so I'm going to make a point in my picture, if I kind of draw it down here, so it might be a little easier to see, that this is 5, this is 8, and I'm looking for that angle. This is the opposite, that's the adjacent. I'm going to use tangent to solve so that I don't have to use my hypotenuse here. So tangent of angle A is equal to 8 over 5, and since I'm looking for the angle, let's use that inverse tangent. And so grab your calculator, second tan, 8 over 5, we come out with 57.99 and change. So to the nearest tenth, this would actually be 58.0 degrees. All right, there's that angle A. All right, if you trust your work, then to get the measure of angle B, which is this guy up top, I'm just going to do 180 minus 90 minus that 58, or a shortcut to get angle B, I could just go 90 minus that 58.0 right there. If you still have that exact number in there, feel free to even go 90 minus and grab that value and then get it. This way you feel confident about that answer. Either way, we should be coming out as 32.0 for that angle B right there. All right, and then the last thing, to find the area of the triangle. Remember, area formula is 1/2 base times height. Your base and your height are the two legs of that triangle. So 1/2 of 5 times 8. Get that final answer. It's your video question, and finish on up your notes. Thanks, guys, for watching.